Ryan, you brought your rock collection?
Yep, this is all it.
Yeah. Tell me what we got here.
We got 2 pieces of the moon here that for everyone to see. So this is an Apollo 11 basalt, and this is an Apollo 17 basalt. So it's from the first and last mission. Same rock type from very different places on the moon.
Really? These are older rocks then. I mean, how long ago was that mission?
So this Apollo 11 was in 1969, and Apollo 17, the last one, was in 1972. So at this point, we're almost 50 years ago for both, 53 almost for the Apollo 11 mission.
And you were saying they're a salt rock?
Basalt.
Basalt.
So it's the most common rock type on Earth. Like if you go to Hawaii, all the lava you see coming out of those are basalts. And so we have the same rock type on the moon.
Wow.
The details about the rocks on the moon are a little different than the ones on Earth. There's some cooler stuff about it.
So the moon is one big lava formation?
Sort of. So we think the moon originally formed through a giant impact, and so there was just such a big impact that hit the Earth. There was a big ring of debris that collected into our moon, and there was so much energy involved in that process. The outer hundreds of kilometers of the moon liquefied, and so we had an ocean of magma covering the entire moon. And then as that cooled, then we had different rock types coming out of it.
Would these both be surface rocks?
So these are both surface rocks. The one thing about moon rocks that sort of isn't as good as what we have on Earth is that all the rocks come from near the surface, or relatively near the surface. On Earth, we have a process called plate tectonics, which moves rocks up and down inside the planet. The moon doesn't really have that, and so we get stuck with just the outer veneer a little bit more on the moon.
How far have we ever tried to dig into the...
3 whole meters.
Okay.
It's really hard to dig on the moon. So they took 3 3-meter drill cores, one each on Apollos 15, 16, and 17.
So you were saying this is a touch rock?
Yeah.
As in I can touch it?
You can touch it till... No, I'm just kidding.
What's this? You look through there?
That's the security bar.
Okay.
That's for when we mount it in the museum. That's the key
smooth.
piece. Yep. So we didn't polish it, but we did grind it flat so that there weren't any places where people could pick at it.
Yeah,
you'd be surprised. Right. The first thing everyone wants to do is take a little bit home with them. Yeah.
I will say, I asked my son what I should ask of an astronaut or whoever at NASA, and he said, well, get me a moon rock. So
it turns out
you can't make that happen.
So you can't get an Apollo sample, but there are moon rocks that are out there for the public to own. They're called meteorites.
Oh.
So, our astronauts went and got the rocks and brought them back, and they're very special, and they came from a known place.
Right.
But random impacts into the surface of the moon blast material off all the time, and that material falls to Earth, and it falls all over, and there are lots of them that are available for sale. And so you can actually bring for sale, but we don't ever sell Apollo samples, only meteorites.
So here's 2 rocks.
Yep.
How many rocks have we collected?
So they brought back 2,196 individually numbered samples from the moon. They weighed 842 pounds collectively.
Wow.
Yeah.
Give or take 1 or 2 rocks.
No, actually, that's not how we do things. 2001, no, I'm just kidding. Yeah, it depends on how you group them, because they didn't collect 2,196 things. They would collect just soil.
Yeah.
And anything bigger than a centimeter, they would separate it out because it's its own rock.
Right.
So I don't actually know how many things they scooped up off the surface. Sure. I've never added that up. But
What have we learned from collecting rocks from the moon? Like, how's it changed us down here on Earth?
So much. I mean, Earth is an active planet. We have plate tectonics and stuff. The oldest rocks on the surface of the moon, the surface of Earth, are only about 3.9 billion years old, which is really old. But the solar system's 4.5 billion years old. And that first 600 million years, that's where all the action happened. And so almost every rock on the moon is older than every rock on Earth.
Wow.
And so by going back and studying rocks on the moon, we're able to learn about the Earth-Moon system, because they came from the same body, and really unravel the very earliest history of our solar system. And, we study the moon directly by studying moon rocks, or we study the Earth. But we've also been able to study other planets like Mercury and Venus and Mars, even Jupiter, Saturn, Uranus, Neptune. We've learned something about all the other planets by studying rocks from the moon, just by being clever with how we use them.
Right.
Yeah.
Any fascinating distinction between the rocks that you guys collect or the samples as far as color, size? I mean, basically, you get a moon rock, it's going to be about like that.
I mean, the rocks, varied in size from microscopic, because the soil is made up of individual grains, to the biggest one they brought back was called Big Muley, and it was so big it wouldn't fit in the claw that they designed to pick it up. So there's a great picture of Charlie Duke on Apollo 16 rolling it up the leg of his spacesuit and into the bag, which is not the preferred collection method. But it turned out to be a really cool rock, and it weighed almost 13 kilograms, so 26 pounds. It's bigger than a football. That was individually half as much as the entire Apollo 11 collection collected.
I hear a lot of people having some interest in asteroids and other minerals and things that we can collect from space, because we think we can find usable minerals or things like that we could put, like as an example, into our electronic devices and things like that.
Yep.
And supposedly it's worth a significant amount of money. Are we trying to do that? Are we making progress toward collecting these things to utilize in devices down here?
There are a lot of people who are looking to do that for asteroids.
Yes.
It won't work as well on the moon.
Right.
You need a mechanism to concentrate the elements, and the moon doesn't have those. The way we do it on Earth is through plate tectonics, recycling of crust, and water. Like liquid water moving around, and it moves things around. And we don't have either of those on the moon.
Right.
We don't have them on asteroids either, but they were small enough. The entire body was able to differentiate. So you can get at the core, the metal core of the entire planet, just like the Earth has. So if you can get one of those metal cores, there's so much good stuff in there. The moon has a metal core, but it's 1,500 kilometers beneath the surface. That's tougher to get at. The moon breaks apart, then we can get at it.
So you get the right asteroid, you can get into the core, collect some of those metals, and utilize them for...
That's the plan. It's expensive to go up and down.
Sure.
And so at a certain point, it'd be great to use them in space.
Yeah.
And a lot of what they talk about for the moon, for mining on the moon, is not to bring it back to Earth.
Yeah.
It's in situ research. It's to let the astronauts help live off the land, so they don't have to bring all their water or oxygen with them, maybe even building materials. So there is a lot of work on that, but it's not like commercial. It's not commercial strip mining of the moon.
It's been a while since we've been to the moon.
It's so exciting to go back. There's so much more to learn. People are always like, you have 842 pounds of moon rocks, why do you need more? And the answer is, I'm greedy, just like all rock collectors. But really, it's because we only went to a relatively restricted area, the near side of the moon.
Sure.
And it turned out to be an unusual spot, and that's great.
Yeah.
But it would be like studying the rocks in Texas and thinking you knew about the rocks in the whole United States, and you just don't. And how the whole planet formed. And so,
we need to go to the dark side of the moon.
The far side of the moon.
Yeah. See if Pink Floyd's up there.
Yeah. Yes. I mean, literally any place you could go on the moon, you would learn something important. But because, Artemis is going to go to the south pole of the moon, that's the far side of the moon, that is the southern highlands. It's near where we think there might be permanent water deposits and permanently sunlit areas. All of those are going to be completely new processes on the moon. It's also on the rim of the largest and oldest crater in the solar system, the South Pole Aitken Impact Basin. And so I said we like to learn about early history. This thing is 4.4 billion year old impact crater that's 3,000 kilometers across. It almost broke the whole moon apart. And so that will have dug as deep as anything on the moon. So getting the material out of that and figuring out what it is will help us understand the deep interior of the moon and really understand how planets other than Earth are made up inside.
So we've got moon rocks.
Yep.
We've got rocks from asteroids and things like that. Do we have rocks from any other planets?
Sure, we actually have rocks from Mars. Now, we've not actually gone and got them and brought them back ourselves, but the whole lunar meteorite process I was talking about earlier, how just random impacts throw stuff off the surface, same thing happens on Mars. And so we have a couple hundred pieces of Mars that have fallen to Earth over the last 100 years or so. And so scientists have been able to study those and directly study Mars as well.
So nothing we've collected from the surface necessarily, but...
I mean, there's a rover there right now, Mars 2020, collecting rocks to bring back from known locations, but we have these random rocks from the surface that we have had in our collections for a long time.
Is it difficult to figure out, like when, rock falls from the sky, like, well, where'd this come from?
It is if you don't have a point of comparison. And so they had Martian meteorites since like the late 1800s, but they didn't know they were from Mars. There were some estimates, there were some guesses, but then after the Viking landers in the 70s, they measured the atmosphere. And then they took the meteorites and they heated them up, and the atmosphere that came out matched the Viking landers, and it didn't match anything else. And so that was sort of the smoking gun to be like, these are definitely from Mars. And then you could really start unraveling Mars history using those rocks. And so,
So measuring atmosphere.
Measuring atmosphere.
What about carbon dating? Does that play into any of this?
I mean, carbon dating would work, except carbon dating has a half-life of about 5,000 years. So you can only go back about 20,000 years. And so these rocks are billions of years old. We use the exact same technique with just different isotope systems, uranium, lead, samarium, neodymium, stuff like that. And it's the exact same process, but it lets us stretch the timeline back for billions of years instead of thousands of years.
This video is inspired by our PBS series, Reconnecting Roots. Connect with me, Gabe McCauley, and Reconnecting Roots by visiting reconnectingroots.com, where you'll discover music, blogs, behind the scenes, our podcast, and more. Join our email list and never miss a beat.